but we can go to moon in a week, right? Week up and back in a week or so. But we can send our robotic craft and they'll get there in our lifetime. We'll talk about what just happened 2 summers ago for Pluto. So here's the key idea. How big, and we're going to use y, which is like about how many diameters of Earth tells interior warmth, etc. Everything that comes, the releasing of gas, the volcanism, the holding of an atmosphere. So knowing that tells you quite a lot. And then how far from sun tells you surface warmth or cold. And so getting a sense of this is important before you sign up to go to Mars. Likely the shortest trip to Mars and back might be 2 years, and that time your bone density would reduce dramatically. Anybody in the hospital, even for 2 weeks, your bone density decreases, your heart gets weaker, all that stuff. Likely you would not be able to come back and acclimate to Earth. That's the plan. But there are things that you can do, so people are working on that. But more than likely you wouldn't be able to come back. We'll talk about some of that reason. I know people that would do it, honestly, and I think that they would, but that's like okay, I'm going to die doing this. Like, all right, you go for it. I like sunsets and pizza. So, you know, I'm good. Moon, I'd have to think about it. It's like, it's dangerous, super dangerous. Even going in orbit's dangerous, but I would think about it. Mars, not me. But, you know, Matt Damon did it, so. So, good movie. Really well done. What's it called? The Martian? Was that? It's real. If you haven't seen it, it's really well done. I love it when they do movies. Contact. It's a lot of good movies. All right, let me get this out of my way. Well, I have memory aids for you. So it'd be crazy. How can I remember how wide and how far apart these things are? Because I got memory aids. So let's do one real quick. A little bit of a squeeze. We'll have to touch this up next time. Today's Thursday, isn't it? All right, so here's how we're going to do this. Read the book. If you read the book, it's going to be a lot easier, and you will get used to it. You don't want to do anything unreasonable, but I want to give you enough substance to make it interesting and valuable. So here we're going to do, I have memory aids. So we're going to do the inner four, how wide and how far apart, and then the outer four. Good news, the outer four, which we'll do on Tuesday, is fast. Then we'll get on to studying Mercury. What's up? Any mountains, any volcanoes, any horses? So here's this, I've got this thing here, so I'm going to go right here and cut it off. Maybe I'll bring it up here. Yeah. Here's the key for the inner four. It's in the book, so I'm not going to write a ton here, but I'm going to give you something that's not in the book. So we're going to do a little game to visualize this. Let's see if I think I can do it. Good old Earth. Now we don't need exact numbers. That's just ridiculous. I hate that. Books give you exact numbers and then they give it in kilometers, which the rest of the world uses, but this is for, the U.S. and we're not used to kilometers. So here it is. So when I talk about how wide, and let's make a little chart. Again, not in the book, so maybe worth writing down. We're going to do the inner four. I'll just put to rest. Planets. we're just going to use simple fractions. They're good enough. So I just looked at the actual numbers and was trying to find patterns. Like, how can I remember this? How can I help people remember this? Because it's so valuable. And we're going to look at the widths are about how many diameters of Earth. And remember that the width tells you about the interior warmth. You know how cold the moon got. And then we're going to compare that with the distances. And in this one, we're going to do distances from sun. Are about how many AUs. Do not confuse an AU with a DE. Remember, an AU is here to the back wall. A DE is a grain of sand. Everybody got that? You can print that? Let it in. Don't fight yourself. Don't talk yourself out of it. You can do this. Okay, so DE versus an AU. In this one, I don't use these distances because there wasn't as good a pattern. But once you know it, you know it. Okay, so here's what we're going to do. We're going to say, like, the diameter of Earth is about, well, how many DEs? Yeah, it's hard, huh? 1. Good, all right. That's what that means, right? That's how wide it is. But your game is now the diameter of blank is about, I'm going to do the simplest fraction. So I'm going to go 1, 2, 3. How many are there? 4. 4. But the pattern keeps on going, so I'm going to give you bonus today. Only today, though. And we're going to compare with DE, the diameter of Earth, the width of Earth. And we're going to use simple fractions, and these are pretty simple, right? 1 over 1. I know I could say 1, but the pattern is nice. 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5. Pretty cool, huh? Pretty good. And you have to figure out who is there. And then the other, let's figure this out, is you're going to, how many AU from sun? 1, I got 1, 2, 3, 4, 5, 6 here, which is interesting. Okay. How many AU? How many AU? How many AU? And then we're going to connect this column to that column. 1, 2, 3, 4, 5, 6. Okay, that's our little framework. So one world, you with me? One world is about the same diameter as Earth. One world is about half as wide, half as wide, half as wide that way. One world, you get 3 across, 3 across, 3 across. Some books talk about volume, but I think it's easier to visualize the width. One world is, and I lost this one, hint, hint, 4 across, 4 across, 4 across, and one world, 5 across. Cool? Everybody gets what that means. So that's pretty close, and seeing it this way is kind of nice, and then we'll draw it in 2D. Probably have to do that next time. Read through the book here. Okay, so what I need to do is show you to help you. So you got to visualize these pictures, and I'm going to go here, and I'm going to show you these pictures. You know the order, so that's going to help you for the distances. Remember my very excellent mother, and you're good for these. Okay, so given this picture, fill in the blanks. Who's 1 over 1 width of Earth? Who's 1 over 2? Who's 1 over 3? Who's 1 over 4? Who's 1 over 5? One's missing in here. but you know that one, so go for it. Number 1, number 2. Who's 1 over 1? Thank you, artists. I don't know where we would be without artists, quite frankly, so thank you, you artists. So many ways. These aren't real pictures. I don't like the colors here. Mars is fine, Earth is fine, Pluto's, we now know better than that. Mercury's, that's a weird color, and that's a really weird color. I'll show you those. So who's this guy? Venus, right? There's a reason I do this is for my moon, but this is also for Venus. It's Venus. So did you put Venus in here? Now you can put V, it's fine because there's only one V, right? Who's half as wide as Earth? Mars. Now you can't put M because there's Mercury and there's Moon, so got that. Cool. And then who's a third? Mercury. So go ahead and put that in there. Right? And then who's a fourth? Moon. Right? You know that one from before, so don't forget that Moon's in there. It's a subscript. And who's a fifth then? Pluto is even smaller than Moon. You know, so that's another reason to pick on it. Pluto. Mars. Cool? Okay, now we need simple fractions here. Well, now I'm going to put these guys, too much junk here, but I'm going to put these guys in here between Earth and Sun. How far is Earth to Sun? So how would I evenly space? Who goes first? Mercury. Which one is Mercury? How wide? 1/3. Who goes second? Use the memory aid. My very excellent. Who's next? Well, on my list, don't forget that guy. And then Mars, right? Out here somewhere. How far away are they? What would be the easiest fraction from here to here? What is this? 1. So this is what fraction? 1/3. 2/3. So I'll give it to you this way since we're rolling. If I say 1/3, 2, look how nice that is. 1/3, 2/3, 3/3, 3/3. Whoa, did you do something wrong? No. 1.5 and 30 to 50. And I connect these guys. Who's 1/3 of an AU from Sun? My very excellent mother. Who's 2/3? Now look at Mercury. How cool is that? Don't confuse them. They're different things, but it just approximately works. Venus not so nice, but oh well. Who's 3/3? Earth. Who else is 3/3? Moon. Remember, it's just a grain of sand back there, so they're right next to each other. Who's 1.5? 1 and farther out, my very excellent mother is. Whose mother? Right, Mars. Which is pretty cool, right? I mean, it doesn't get much cooler than that. You got a half in there. We have all kinds of twos for Mars, all kinds of 3s for Mercury. Who is 30 to 50 AU away? That's a long ways out there. Spacecraft takes 9 years to get there. Talk about that. Cool, thanks for bringing in there. A little extra. And try to review this sometime today because your brain will dump it, which is an annoying thing of our brains. And do some of the exercises, some of the homework. Good. We're basically done. We'll just finish that up and start on chapter 8 next time.